In this video, we are going to solve different problems on indices. To start with, simplify 5x raised to negative 2. Now, in this question, we need to first write 5x raised to negative 2 as 5 times x raised to negative 2. Now we can see that it is only x that is raised to negative 2, and we can now follow the reciprocal law. Then we say 5 times 1 over x raised to 2. This gives us 5 over x squared. Another one, 5 raised to negative 2 times 5 raised to 0. We have 1 over 5 squared following the reciprocal law times any number raised to 0 is equal to 1. And so the final answer is 1 over 5 squared, which is 25. Another problem, 36 raised to negative a half. This one, we first follow the reciprocal law of indices, and this gives us 1 over 36 raised to a half. But we know the same as 1 over the square root of 36, which is simply 1 over 6. Another problem is the cube root of 1 over 25x raised to 216. And so this is the cube root of 125. We do that separately. Cube root of 125 is being multiplied by the cube root of of x raised to 216. Now, in this case, we are going to get 5, which is the cube root of 25. But for this one, to be able to solve it easily, just convert it to 216, or get to have 216 over 3, and that simply gives you 5 times x raised to 72. So the final answer is 5x raised to 72. Another problem is 2a squared raised to negative 2 divided by negative 8a raised to negative 2. Now we apply the reciprocal law of indices. We get 1 over 2a raised to 2a squared, raised to 2, divided by 1 over negative 8a squared. Now this one becomes 1 over 4a raised to 4. We open the bracket, we square this to get 4, and this we multiply the powers to get a raised to 4. Then we change the division to multiplication. This becomes negative 8. We are going to square negative 8a basically over 1. Now if you open the bracket, negative squared becomes positive. Maybe I can just write that 1 over 4 a raised to 4 times negative 1 squared. I'm removing the negative to make it negative 1, then 8 squared, then a squared. So this one simply becomes 64 a squared over 4 a raised to 4, and this 4 goes here 16 times, so we have 16, and then a, we remove the 2a by subtracting it from 4, we get that the numerator does not have a anymore, and the denominator will have a squared. Another example is 8 raised to negative 3x equal to 1 over 4. If we are told to find x, again we will start by writing 1 over 8 raised to 3x using reciprocal law is equal to 1 over 4. Now at this point we write them to a common base, where we are going to have 1 over 8 can be written as 2 raised to 3. So we have 2 raised to 3 raised to 3x is equal to 1 over 4 can be written as 2 raised to 2. So here we open this bracket and get 1 over 2 raised to 9x is equal to 1 over 2 raised to 2. Then in this case, since the bases of the denominators are equal, we can equate the powers of the denominators also, and we get 9x is equal to 2, x is equal to 2 over 9. Another example is where we have a equation to solve. We are told to solve for x in the equation 27x times 3 raised to 2x minus 2 is equal to 9 raised to x plus 2. 9 raised to x plus 2. Now in this one you need to write all of them to a common base, and we end up with 27 as 3 raised to 3, 3 raised to 3, and there is x here, so we end up with 3 raised to 3x. We multiply that by 3 raised to 2x minus 2, and we equate to 3 raised to 2, that is what 9 is, into bracket x plus 2. What we end up with is 3 raised to 3x plus 2x minus 2 is equal to 3 raised to 2x. I'm opening the bracket here, 2x plus 4, and that gives us again two indices which have common bases and they are equal, and so we say the powers are equal. We therefore write 3x plus 2x minus 2 is equal to 2x plus 4. Now we collect the like terms here. We have this will cross this equal sign, and when it comes this side it will be a minus, it will cancel with this, and so we end up with 3x is equal to negative 2 will go this side and we'll add to 4, we get 6. So we have 3x is equal to 6, and therefore x is equal to 2. Another example is 2 raised to power 6 multiplied by 64 raised to power negative 1 over 3. All this divided by 9 raised to negative 3 times 81. To solve this, we need to start by writing 2 raised to 6. We multiply by this 64 can be written as 2 raised to power 6, and then we raise it to negative 1 over 3. And then the denominator, we are going to have 9 can be written as 3 raised to 2, then we raise it to negative 3. Then we multiply by 81, which can be written as 3 raised to power 4. And so the next step would be to open the brackets that I've created here, and we have now 2 raised to power 6. We multiply by 2 raised to, if you open this, you multiply 6 and a third to get negative 2, because there is a negative here, it turns this to negative, and then the denominator becomes 3 raised to negative 6. If you open this part, then we multiply by 3 raised to power 4. As you can see, the denominator and the numerator have common bases in each case. So in the numerator, we can multiply these together. We get 2 raised to 6. We add negative 2. If you add negative 2, is the same as subtracting 2. And the denominator, on the other hand, we are going to have 3 raised to negative 6 plus 4, and this gives us 2 raised to 4 over negative 6 plus 4 is going to be 3 here raised to negative 2. Negative 6 plus 4 is negative 2. Since if we use number line, we can be able to tell where that value is. We have negative 6, negative 5, negative 4, negative 4, negative 3, negative 2, negative 1, 0, 1. Now, if we have negative 6, when we add, we move towards the positive side or towards the right hand side. So we add from 6, we add 1, 2, 3, and 4, which gives us negative 2, as you can see here, which is actually the answer I've written. Now this question up here, we have not completed it, because if we move on, you realize this, we apply reciprocal rule that gives us 2 raised to 4 times 3 raised to 2. Another example is where we have 4a raised to 3 times 3x squared. All this divided by 2 raised to 2 a raised to 4 multiplied by 2 raised to 2x. 2 raised to 2x. Now, to begin with, you can be able to see that we have x here and we have x here. You can simplify by subtracting. Here we subtract 1 because this is x raised to power 1. And in this other case, we can subtract the reverse way. We subtract 3 from 4, and 3a will go away. A in the numerator, a will go away, and in the denominator we'll be left with only 1a. So we can start by doing that, and we write 4 in terms of 2. So 4 becomes 2 squared, and we multiply by 3x. 1x has been taken away through subtraction of powers, and then the denominator we have 2 raised to 4, 2 raised to 2, and then again here we only have 1a left in the denominator, and at this point here we have times 2a, 2 raised to 2, there is no x. Now at this point again, we can simplify this by taking this and this, cancelling. We will be left with 3x over 2 squared a as our final answer. Another example is when we have 1 over 8 raised to x is equal to 1024, and we are told to find x. Find x. To find x here, we simplify this by writing it as 1 over 2 raised to 3 raised to x is equal to, this 1024 becomes 2 raised to power 10, because 2 raised to power 10 gives us 1024. At this point, we apply the reciprocal rule for the left hand side to get 2 raised to negative 3x. I've opened the bracket also. I'm multiplying the powers. I get this is equal to 2 raised to 10. So since the two indices are equal and they have the common base, then we can say their powers are also equal. So this gives us 3x, negative 3x is equal to 10. Therefore, x is equal to 10 over negative 3, which gives us negative 10 over 3. You can simplify this to negative 3 and 1 over 3, or you can leave it as an improper fraction. Another example is where we have 1 over 4 raised to negative n is equal to 1 over 2. Now, in this case, we write the left-hand side as 1 over 2 raised to negative 2n. Of course, if you look at this, you'll realize 4 is 2 raised to 2. And so I've opened that bracket. I've gone one step ahead. Now, if you look at this, 1 over 2 can be written as 1 over 2 raised to 1. You can see that these sides are equal. They are both equal. And hence, we can write as negative 2n is equal to 1. The powers here are the same as these powers if these two indices are equal. Therefore, negative 2n is equal to 1. That gives us n is equal to negative a half.